You do not have the combination of x and a, isn't it? So therefore here adding and subtracting x and then writing 2a as a plus a. Consider this 1 as a, it is a constant. So it is like x squared minus a squared, isn't it? See here, x squared minus a squared. So therefore you can substitute x as secant theta. Always if you reducing to the form of either a squared minus x squared or x squared minus a squared, coefficient of x squared must be equal to 1. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have learned many problems on trigonometric identities. And in today's session, dear students, here we are having session number 7 and a chapter number 7 from your NCERT called Integrals. And what are all the topics we are going to study under this session is nothing but integrals of some particular functions. Therefore, here you are going to learn some formula proof and then based on that formula, you are going to learn the problems which will be asked for a 5 marker in your final examination. That means along with this formula proof, they are going to ask you one problem which is given for a 1 marker. That means related to the formula only they are going to give you a problem. I hope you got this one. Now we'll be moving on to solving the problems. Here solving the first formula what they have given. Prove that integral of dx divided by x squared minus a squared is equals to 1 divided by 2a into log of x minus a divided by x plus a plus c. Dears, here let me take the left hand side and then prove the right hand side. We'll be having a left hand side as like, left hand side implies integral of dx divided by x squared minus a squared. Now, dears, I am writing this x squared minus a squared as, according to the formula, a squared minus b squared is a plus b into a minus b. So therefore, a replaces here x and b replaces here a. That's it. So integral of dx divided by x plus a into x minus a. Right? So, right hand side you can see, dear students, you are having 1 by 2a. Therefore, here I am going to divide by 2a. If I am going to divide by 2a, I have to balance the step. I have to multiply that by 2a also. Therefore, multiplying and dividing by 2a. So, 1 by 2a, it is a constant. It can be taken to outside the integral. 2a divided by 2a will get cancelled. You are going to remain with the same step. And denominator as same, x plus a into x minus a into dx. I hope you understood this step. Now dears, I am going to make here denominator you are having the combination of x and a, but the numerator you are having only a. 2a can be written as a plus a, and then since denominator I am having in the terms of x and a, numerator also I am going to make in terms of x and a. Therefore, if you do not have x in the numerator, I can do according to the mathematics rule, adding and subtracting that x, right? So therefore, here I am going to make an 1 by 2a into 2a can be written as a plus a. Along with that, I am going to add x and then subtract x. So adding and subtracting, it will get cancelled going back to the same step. Denominator as it is x plus a into x minus a into dx. Now dear students, I am going to rearrange the numerator as like this, which is 1 by 2a into integral of, see, x plus a, one term of x plus a, this along with this x and along with this a I am going to add, and from this minus x I am taking minus sign common factor. So a will be remaining here, again minus sign common factor if I am going to take from both, remaining is x minus a. If you multiply minus x minus into minus plus a only you are getting. I hope you got that step. Divided by x plus a into x minus a into dx. Now here I am separating this x plus a along with this the denominator minus x minus a along with the denominator, then I am separating the integral as well. So therefore here writing 1 by 2a, that is the LHS, correct? Integral of, see, integral of first term is x plus a divided by denominator as it is x plus a into x minus a into dx. Again, so minus is there, I am writing minus symbol, integral of x minus a divided by x plus a into x minus a into dx. And close the bracket since you are multiplying 1 by 2a outside. Now here, one term of x plus a, one term of x plus a will get cancelled. Remaining is 1 over x minus a. Therefore, 1 by 2a into log 1 integral of 1 divided by 1 by 2a into integral of 1 divided by x minus a into dx minus integral of 1 over x minus a will get cancelled, x plus a into dx. Now dear students, you know integral of 1 over ax plus b is nothing but log of modulus of ax plus b divided by a. So here coefficient of x is nothing but 1 divided by 1 will be giving you the same thing. So no need to worry about the denominator. Now here you are having 1 divided by 2a into integral of this will be giving you log of modulus of x minus a divided by 1 again minus log of modulus of x plus a divided by 1. Coefficient of x is in both, it is 1 itself. Now you are having this is according to log m minus log n. What is log m minus log n? Log m by n, which will be giving you 1 divided by 2a into log m divided by n, correct? Modulus of that plus c. After integrating, please do not forget to write plus c. This modulus we can write it together, which will be 1 by 2a into log of modulus of x minus a divided by x plus a plus c. And this is your right hand side proof. And that's what they are asking you to prove. I hope you understood this one. Now we'll be moving on to the next problem, dears. What they've asked next problem? They've asked, prove that integral of dx divided by a squared minus x squared is equals to 1 divided by 2a into log of modulus of a plus x divided by a minus x plus c. So here also I am taking the left hand side. What happens the left hand side here? That is LHS implies integral of dx divided by a squared minus x squared, which can be written as integral of dx divided by a squared minus x squared. I am writing a plus x into a minus x. So here I do not have 2a because right hand side you are having 2a for the proof. So here also I am going to multiply and divide by 2a whole over a plus x into a minus x into dx. Here you can observe in the numerator you do not have x term because denominator it is a combination of x and a. So therefore I am going to add and subtract x to the numerator and writing 2a as a plus a. So dears, here in the numerator you do not have the combination of x and a, isn't it? So therefore here adding and subtracting x and then writing 2a as a plus a. So therefore, here I am writing 1 by 2a into integral of 2a as a plus a, adding x, subtracting x, divided by a plus x into a minus x into dx. Dears, again I am going to rewrite or I am going to rearrange the numerator as first term as a plus x. I am writing along with this a, along with this x, and then plus here having a minus x divided by a plus x. Remember plus is there in between here into a minus x into dx. Now again dividing this each, you are getting integral of, that is LHS, 1 divided by 2a into, I am separating the integral dear students, a plus x divided by denominator is a plus x into a minus x into dx. Again dears, you are having plus symbol in between, so plus integral of a minus x divided by a plus x into a minus x into dx. So therefore, you can have a cancellation of a plus x here. So remaining is 1 divided by 2a into integral of a plus x will go 1 divided by a minus x into dx, plus here a minus x will go, remaining is 1 divided by a plus x into dx. Now integrating this, you know, here it is nothing but a coefficient of x is here minus 1, coefficient of x is here plus 1. Therefore dividing that one, you are getting, which implies 1 divided by 2a into integral of 1 divided by a minus x is nothing but log of modulus of a minus x divided by minus 1 plus log of modulus of a plus x divided by plus 1, because coefficient of x is plus 1 here, plus c. Dear students, I am writing it as, this is negative of the term will be a negative only. So 1 divided by 2a into, first I am writing the positive term, log of modulus of a plus x, and then I am writing the negative term minus log of modulus of a minus x plus c. Now this is according to log m minus log n, and along with the modulus symbol I am writing it together. Therefore you are getting the proof will be equal to 1 divided by 2a into log m by n. You can write it as, that is modulus of a plus x as a first term divided by, because it is a positive, negative a minus x plus c. And this is your proof of the RHS. I hope you understood this proof also. And be careful while adding and be careful while doing the integration, considering the coefficient of x there. In the last case, the coefficient of x in both was, it is positive 1. So I neglected that one. Here you cannot neglect, since you are having the negative x. It will be divided as negative. Negative into the positive will be negative only. So therefore, negative term I am going to write the next term, and then first positive term I am going to write it as the first term. I hope you understood this one. Now we'll be moving on to the next formula proof. What they've asked, prove that integral of dx divided by a squared plus x squared is equal to 1 divided by tan inverse of x by a plus c. Dear students, if you observe here, you are having in the denominator a squared plus x squared. Since the last case was in the form of a squared minus b squared, we wrote that one in the form of a plus b into a minus b. But this in the case we cannot write like that. So what we are going to do? We are going to do the substitution method. Dear students, right hand side you are having in the form of tan inverse of x by a. So therefore, I am taking, you know the trigonometric identities, 1 plus tan squared theta is equal to secant squared theta. Now why I am particularly concentrating on this? Because right hand side you are having tan inverse. That is a tan function. So I am particularly concentrating trigonometric identity of tan. So here writing it as, in the left hand side, taking and substituting x as a tan theta. Why a tan theta? Because you are having here x by a. So therefore I am going to substitute in the right hand side, put x is equal to a tan theta. So here let me write this left hand side. Left hand side implies that integral of dx divided by a squared plus x squared. Now which implies, if I am going to do the substitution method, all terms should be in terms of that only. That is in terms of theta. So therefore here differentiating with respect to x, you are having dx, 1 into dx is equal to a into a is a constant. Differentiation of tan theta is nothing but secant squared theta into d theta. Now substituting dx as a into secant squared theta into d theta and x as a tan theta. What happens to this condition? Integral of dx is nothing but a into secant squared theta into d theta divided by a squared as it is plus x as a tan theta whole squared. Now a tan theta whole squared is nothing but a squared tan squared theta. Therefore, I can simplify further that one, a into secant squared theta d theta divided by denominator a squared plus here a squared tan squared theta. Now dear students, you can take denominator a squared as a common factor. So a into secant squared theta into d theta divided by a squared into 1 plus remaining is 1 here. A squared already taken common. Remaining is tan squared theta here. Now dear students, according to the formula, we know that 1 plus tan squared theta can be substituted as secant squared theta. Here, one term of A will get cancelled. Denominator A will be remaining. Therefore, LHS implies that 1 by A is a constant. I can take outside. Observe here, 1 by A is remaining. I am taking outside and writing secant squared theta divided by, see dear students, 1 plus tan squared theta I am substituting as secant squared theta, which implies secant squared theta into d theta. Now secant squared theta will get cancelled. 1 by A into integral of 1 into d theta. Now 1 into d theta is nothing but 1 by A into theta plus C. Integral of d theta. 1 into d theta is theta. Integral of 1 into dx is x. Integral of 1 into d theta is theta. That's it. Now substituting back to theta. Now what you are having? X is equals to, see, x is equals to, you are having a tan theta. Now tan theta can be written as, taking this a to this side, it will become x by a, or theta as it is, you can transfer tan to that side, it will become tan inverse of x by a. Therefore, writing theta as tan inverse of x by a, which implies 1 by a into tan inverse of x by a plus c, which is your RHS. I hope you understood these steps. Now, if you are having, according to, depending upon the right hand side proof, we are taking the trigonometric identity. Since we are having here in terms of tan, I have taken the identity as 1 plus tan squared theta is equal to secant squared theta. Now, we'll be moving on to the next proof, dears. What they have asked. Prove that dx divided by under root a squared minus x squared is equal to sine inverse of x by a. Dears, yes, your guessing is right. Right hand side in terms of sine. So here also we are moving according to a substitution of x. Okay, x is equal to what? Yeah, substituting it as a sine theta. According to the identity, sine squared theta plus cos squared theta is equal to 1. Now 1 minus cos squared theta can be written as sine squared theta. So here we are taking the left hand side. What is the left hand side? Left hand side is nothing but integral of dx divided by under root a squared minus x squared. Now substituting as, put x is equal to a sine theta. Now if you put x is equal to a sine theta, you can differentiate this. Dx will be is equal to a into sine theta differentiation is nothing but cos theta into d theta. Now substituting dx as this and x as a sine theta, we are getting the left hand side will be is equal to dx as a cos theta into d theta divided by under root a squared as it is minus x squared whole squared. You are having a sine theta whole squared will become a squared sine squared theta as we have done in the last case. Now we are taking here in the denominator common factor as a squared. So a cos theta in the numerator, denominator under root a squared into remaining is 1 minus sine squared theta into d theta. D as you can observe here, a cos theta divided by under root a squared 1 minus sine squared theta is nothing but, see, if you take to this side it will become cos squared theta. 1 minus sine squared theta is equal to cos squared theta. So substituting this is equal to cos squared theta into d theta. Now what happens to this? Under the root it will get cancelled. You're remaining with, which implies integral of a cos theta divided by a cos theta whole squared under the root into d theta. Now root will go, remaining is integral of a cos theta divided by a cos theta into d theta. Now what happens to this? These two will get cancelled. Remaining is integral of 1 into d theta. What is integral of 1 into d theta? Which is theta plus c. Now we need to substitute for theta. We are having substitution of x is equal to a sin theta, isn't it? Now therefore, sin theta can be written as x by a. Otherwise, theta can be written as sin inverse of x by a. And theta can be written as here sin inverse of x by a, which is sin inverse of x by a plus c. And this is your right hand side proof. Is that easier to prove, dear students? Yes. I hope you got this proof. Now we'll be moving on to the next proof, dears. What they've asked: prove that integral of dx divided by under root x squared minus a squared is equal to log of modulus of x plus under root x squared minus a squared plus c. Now dear students, if you observe here, you can have here in the denominator x squared minus a squared under root and go for a substitution method. Now if you go for substitution method here, either you can substitute which is in the form of x squared minus a squared. A squared is a constant, x squared minus 1, isn't it? Either you can substitute here 1 plus tan squared theta, that is, or you can substitute cosecant squared theta. See, what is 1 plus tan squared theta? 1 plus tan squared theta is equal to secant squared theta. Otherwise, secant squared theta minus 1 is equal to tan squared theta. Consider this 1 as a, it is a constant. So, it is like x squared minus a squared, isn't it? See here, x squared minus a squared. So, therefore, you can substitute x as secant theta or x as cosecant theta. Anything is fine. Okay. Here I am substituting x as secant theta for the left hand side. Now, take the left hand side, which implies integral of dx divided by under root x squared minus a squared. Now, here I am substituting, put x is equal to, since you are having a, so I am substituting a secant theta. If I substitute a secant theta, I have to differentiate this with respect to x, which will become differentiating with respect to x. Now you are getting dx will be is equal to a as it is. Differentiation of secant theta is nothing but secant theta into tan theta, isn't it? Into d theta. Therefore, substituting that in the numerator, you are getting integral of dx as a into secant theta into tan theta divided by denominator under root a squared secant squared theta, because x squared you are having minus a squared into d theta. Now you can observe in the denominator a secant theta into tan theta as it is in the numerator divided by under root. You can take a squared common. If you take a squared common, remaining is secant squared theta minus 1 into d theta. Now dear students, you can write this one as a secant theta into tan theta divided by this, you can write it as under root of a secant squared theta minus 1 as nothing but tan squared theta. Therefore, a tan theta whole squared. Now dears, root will get cancelled. You are going to remain with the numerator as integral of, which implies of the left hand side, a secant theta into tan theta divided by in the denominator as a tan theta into d theta. Now you can observe tan theta, a will get cancelled. Remaining is integral of secant theta into d theta. So dear students, you know integral of secant theta can be written as log of modulus of secant theta plus tan theta plus c1. I am telling you why I have written c1 rather than c. So here secant theta, you know the substitution is nothing but here, see, secant theta is nothing but x by a, isn't it? Now you have taken x is equal to a secant theta. Now secant theta can be substituted as x by a, isn't it? Now what happens to the tan theta? Tan theta you are having, see, tan theta is secant squared theta minus 1 under the root. Therefore, writing here tan squared theta is secant squared theta minus 1. Otherwise, tan theta is under the root of secant squared theta minus 1. You can substitute secant theta, which is x by a, which will become x squared by a squared minus 1, because x by a whole squared. So tan theta I can substitute as what? Tan theta will be is equal to under the root of x squared minus a squared minus 1. Therefore, substituting here, we are getting log of modulus of this will become x by a plus this will be under the root of x squared by a squared minus 1 plus c1. Again, this can be written as, which implies log of modulus of x by a plus under the root of x squared. See, LCM is a squared into 1 is a squared divided by a squared plus c1. Now dear students, you can take under the root for both, right? Therefore, we can write it as, which implies that log of modulus of x by a plus under the root x squared minus a squared divided by under the root a squared plus c1. Dear, under the root a squared will become what? It will become a only. Now dear students, you came to know about the substitution what I have done. Now here you can take it as, which implies log of modulus of x by a, that is root a squared will become, I am writing that x by a under the root of x squared minus a squared divided by a plus c1. Now this can be written as log of modulus of x plus under the root x squared minus a squared divided by a, because this is as taking the LCM plus c1. Now which will become, this is log m by n. What is log m by n? Log m minus log n, which will become log m is the whole term, which is modulus of x plus root of x squared minus a squared minus log a plus c1. Now here you can write it as log of modulus of x plus under the root x squared minus a squared plus c, where you can have c will be is equal to c1 minus log of a, that is modulus of a. Okay, because mod a you are having. That's it dear students, and that is a proof we are having log of modulus of x plus under the root x squared minus a squared plus c. I hope you got these steps. Now we'll be moving on to the next problem. What they've asked: prove that dx divided by under the root x squared plus a squared is equal to log of modulus of x plus root of x squared plus a squared plus c. Dears, here also you're having in the substitution of what? 1 plus tan squared theta, correct? Is equal to secant squared theta. Now if you assume this one as a plus a squared plus x squared, you can substitute x is equals to here tan theta. Therefore, taking the left hand side and substituting x as under the root x squared plus a squared. Now taking here x is equals to a tan theta. If you substitute x is equal to a tan theta, dx you are going to get a secant squared theta into d theta. Therefore, substituting this will be implies that integral of dx as a secant squared theta divided by under the root x squared as you have substituted a squared tan squared theta plus a squared into d theta. Now which will become implies integral of a secant squared theta as it is divided by, write it as by taking the a squared common, a squared remaining is tan squared theta plus 1 or 1 plus tan squared theta. But what is 1 plus tan squared theta? It is secant squared theta. So substituting that you are getting, which implies integral of numerator is a secant squared theta divided by denominator is under the root a squared into secant squared theta into d theta. Now you can write the denominator as a secant squared theta divided by a secant theta whole square under the root. So root will get cancelled. You are going to remain with the answer integral of a secant squared theta divided by, you are having a secant theta into d theta. Now one term of secant theta will get cancelled, a will get cancelled, remaining answer will be is equal to integral of secant theta into d theta. Now you know already what is secant theta into d theta, which is nothing but log of modulus of secant theta plus tan theta plus C1. Here also why I have taken C1? Because log A will come there. Now substituting as, what you are getting? Tan theta is equal to x by A, and what is secant theta? You know that secant theta according to this can be written as secant theta can be written as C under the root 1 plus tan squared theta. Now which will become under the root 1 plus x squared by a squared, because tan theta as x by a. Here you can observe tan theta is x by a. So substituting in the formula, we are getting log of modulus of secant theta as this one under the root 1 plus x squared by a squared plus tan theta is x by a plus c1. So next will be further simplification gives you, which implies log of modulus of, here under the root c you can observe a squared as LCM, a squared into 1 is a squared, so which will become a squared plus x squared divided by a squared. I am separating the root under the root, again you are having plus x by a plus c1. Now which will become, which implies log of modulus of under the root a squared plus x squared divided by a plus x by a plus c1. Now again taking the LCM as a, log of modulus of LCM will be a, numerator is a squared plus x squared plus x plus c1. Now again this is log m by n. Log m by n is nothing but log m minus log n. Therefore writing accordingly, which implies log modulus of a squared plus x squared under the root plus x minus log of mod a plus c1. Otherwise you can write it as, the answer will be is equal to, which implies log of modulus of under the root a squared plus x squared plus x plus c. So where c is equal to what? Where c is equal to c1 minus log of modulus of a, and that's what the proof. See, under the root of x squared plus a squared plus x, or x plus under the root of x squared plus a squared plus c, and that is your final answer. I hope you understood this one. Now, we'll be moving on to solving problems based on that all formulae. Remember all formulae, dear students, what we have proven till now. Now here they have asked integral of dx divided by x squared minus 16. How we can write this one as? We can write this one as integral of dx divided by x squared minus 16 as 4 squared, which will look like integral of dx divided by x squared minus a squared. Just now we have proven x squared minus a squared integral is nothing but 1 by 2a into log of modulus of x minus a divided by x plus a plus c. Therefore, a replaces here 4, x as it is. Writing according to that one, integral of dx divided by x squared minus 4 squared will become 1 divided by 2 into, so a is nothing but here what? 4 you are having, isn't it? So 2 into 4 into log of modulus of x minus 4 divided by x plus 4 plus c. Further simplification, 1 divided by, you are getting 2 into 4 is nothing but 8 into log of modulus of x minus 4 divided by x plus 4 plus c. This is what the answer. I hope you got this problem. Now this is a problem they are going to giving for 1 marker along with this formula proof. Understood? Now we'll be moving on to the next problem, dears. What they've asked. Integral of dx divided by under the root 2x minus x squared. Dear students, if you observe here, it is not in the form of either a squared minus x squared or x squared minus a squared. But denominator here having a quadratic equation. Now here I am taking that quadratic equation not under the root, only what is there inside the root, which is nothing but 2x minus x squared. Now here I am taking minus common factor, so x squared minus 2x you are getting, correct? Always if you reducing to the form of either a squared minus x squared or x squared minus a squared, coefficient of x squared must be equal to 1. Understood? Now here coefficient of x squared I have made it as 1 by taking minus sign common factor. What I am going to do here, to make it as a perfect square, I am going to take the coefficient of x. Remember, these steps is very important. Coefficient of x is what? 2. So coefficient of x is 2, half of that one. Half of that one means 2 into 1 by 2, which is nothing but 1. Half of this one will be 1, correct? So square of that is 1 squared. I hope you understood this one. Taking coefficient of x, half of that, whole squared of that one. Understood? Now coefficient of x is 2 here, half of that is 1, 1 squared, adding and subtracting that one. Now here I am going to add 1 squared, subtract 1 squared. I hope you understood this step. Now minus of, here you can observe, dear students, this is x squared plus 1 squared minus 2x, which is in the form of a squared plus b squared minus 2ab. Therefore, I can write this one as x minus 1 whole squared minus 1 squared. Now you can multiply minus sign inside, which will become minus of x minus 1 whole squared, minus into minus plus 1 squared. Otherwise, we can write this one as 1 minus x minus 1 whole squared. Therefore, writing the denominator as like we are getting, which implies integral of dx divided by under the root of this, I can write accordingly 1 squared minus x minus 1 whole squared. Now this will look like integral of dx divided by a squared minus x squared. So under the root of a squared minus x squared, now substituting x as a sine theta, if you remember. So the proof is sine inverse of x by a plus c. Now according to this, if you take x replaces x minus 1, a replaces 1. So therefore here writing integral of dx divided by under the root of 1 squared minus x minus 1 whole squared will become sine inverse of x replaces x minus 1 divided by a replaces 1 plus c. Otherwise sine inverse of, you are writing the answer will be is equal to sine inverse of x minus 1 by 1 is x minus 1 only plus c. And this is your final answer. I hope you got this problem how to solve. Along with the proof of that formula, they are going to give this type of problem. Now we'll be moving on to the next problem, what they've asked. Integral of dx divided by x squared minus 6x plus 13. Dear students, here also in the denominator, it is not in the form of a perfect square. Either you should reduce to the form of x squared minus a squared or a squared minus x squared. So let me try here, and here you should be having coefficient of x squared always 1. In this problem, you are having coefficient of x squared as 1. Otherwise, you have to make it as 1. Now, taking that quadratic equation, x squared minus 6x plus 13. Now, here, I am writing here coefficient of x is nothing but 6. Don't worry about whether it is a negative 6 or positive 6. Just I am worrying about what is the coefficient of x. Coefficient of x is 6. Half of that will be 3, isn't it? Half of 6 will be 3. Whole squared of that, which is 9. Adding and subtracting that. So therefore here x squared minus 6x plus 3 squared minus 3 squared plus 13. I hope you got this one. Now if you look this one, this is according to x squared plus 3 squared minus 6x, 2 into 3, which is in the form of a minus b whole squared. Therefore I can write this one as x minus 3 whole squared. Here minus 3 squared is there, minus 9 plus 13. So therefore, you are having minus 9 plus 13 is nothing but x minus 3 whole squared minus 9 plus 13 gives you 4. So which will be plus 4. Now you can write this one as x minus 3 whole squared plus 4 as 2 squared. I hope you understood this one. Now writing that equation as which implies integral of dx divided by this x squared minus 6x plus 13 reduced to the perfect square, which is x minus 3 whole squared plus 2 squared. Now this will look like, according to the formula, integral of dx divided by this is x squared plus a squared. Now x squared replaces x minus 3. That's it. X squared plus a squared, you know, the formula will be given by 1 by a into tan inverse of x by a plus c. Isn't it? Therefore, so x squared plus a squared or a squared plus x squared, both are same, which is 1 by a into tan inverse of x by a plus c. Now here writing dx divided by x squared replaces x minus 3. In place of x, put x minus 3 plus a squared is nothing but 2 squared. In place of a, you are going to put 2. So therefore, which implies 1 by 2 into tan inverse of, in place of x, x minus 3 divided by 2 plus c. And this is your answer, dear students. I hope you understood this one, how to do a perfect square, and then according to the formula, how to write the answer. Now they are going to ask you the proof of this formula along with this type of problem. I hope you got this one. We'll be moving on to the next problem, dears. What they've asked. Integral of dx divided by 3x squared plus 13x minus 10. Now, dear students, you have to reduce the given to a perfect square. Now, reducing to the form of that, you are writing 3x squared, whatever given, take it, plus 13x minus 10. Now, I want to make this coefficient of x squared as 1. What I need to do? Divide throughout by 3. If I am going to divide throughout by 3, otherwise, if you take 3 as outside, x squared plus 13 by 3 into x minus 10 by 3. I hope you understood this one. Now, 3 will be as it is, 3 into this coefficient of x squared, I have make it as 1 already. Now, you have to look into coefficient of x. What is coefficient of x? 13 by 3. Half of that will be 13 by 3 into 1 by 2, which is 13 divided by 6. That's it. So, therefore, whole squared of that one. 13 squared is 169 and denominator 3 squared is nothing but 3 into 2. 6 squared is nothing but 36. Therefore, adding and subtracting that, you are getting the answer will be equal to here x squared plus 13 by 3 into x plus 13 by 6 whole squared minus 13 by 6 whole squared minus 10 by 3. I hope you got this one. See, half of 13 by 3. That's it, which is 13 divided by 6. Understood? Now, you are having, see, if you look this one, x squared plus a squared plus 2ab, which is nothing but a squared plus b squared plus 2ab, which is in the form of 3 as it is. This will become x plus, see, 2 into ab. You are getting 2 into ab, which is nothing but 13 by 3, a squared plus b squared. Yes, a 13 by 6 whole squared, correct? Okay. Now you are getting, see, this is a squared plus b squared plus 2ab, which is a plus b whole squared. Understood? Now you are getting here minus, you can absorb 13 squared is nothing but 169 divided by 6 squared is 36 minus 10 by 3. Now you can take the LCM there. If you take the LCM, you are getting 3 into, see, x plus 13 by 6 whole squared minus, so here LCM will be is equal to what? 36, isn't it? So here you are having 169. Now you can multiply this by what? 3 ones are 12, 3s are 36. 12 into 10 is nothing but 120, right? So therefore you are getting this one 3 into, see, x plus 13 by 6 whole squared minus 169 minus 120, which will be is equal to, so if you take it as your minus sign common factor here, it will become minus of, correct? So therefore minus of this one only it will become, so minus of 169 plus 120. So therefore you are having minus of 169 plus 120, it will become 289. 289 divided by 36. Now here you can have 3 into x plus 13 by 6 whole squared minus 289 can be written as 17 squared, isn't it? Which can be have 17 divided by 6 squared. So 17 by 6 whole squared. Now writing this denominator as like this, which will be giving you, which implies integral of dx divided by, you are having 1 by 3. See, 3 is there, 1 by 3 will be outside. X plus 13 by 6 whole squared minus 17 by 6 whole squared. Now this will look like the formula integral of dx divided by, don't worry about the constant, constant will be outside the integral. This is like x squared minus a squared. You are having 1 by 2a into log of modulus of x minus a divided by x plus a plus c. So here x replaces x plus 13 by 6 and a replaces 17 by 6. So according to the formula, if you write integral of 1 by 3 into dx divided by x plus 13 by 6 whole squared minus 17 by 6 whole squared can be written as 1 divided by 2a, 2 into a is nothing but 17 by 6 into log of x is nothing but modulus of x plus 13 by 6 plus minus a is 17 by 6 divided by x plus a. X is x plus 13 by 6 plus a is 17 by 6. Now taking LCM here, you can have, which implies, now 2 ones are 2 threes are, which implies 3 will go to the numerator, 3 divided by 17, already 1 by 3 are having, I am missing this 1 by 3 will be multiplied here. Now 3 also will get cancelled. Now taking the LCM here, log of modulus of this will become x, that is 6x plus 13 minus 17 divided by 6 whole over 6x, taking LCM as 6, 6x plus 13 plus 17 divided by 6. Now here 6 will get cancelled. Remaining is, see, 1 by 17 into log of modulus of 13 minus 17 gives you minus 4. So 6x minus 4 divided by 13 plus 17 gives you 30, isn't it? So 6x plus 30 plus c. So don't forget to write plus c, dear students. It is very important in the formula. Here, by taking 2 as common factor, you are getting, let me write this as c1 because you are getting again one more constant. So therefore it will become 1 by 17 into log of, if you take here 2 as a common factor in the numerator and 6 as a common factor in the denominator, you are getting 2 into x minus 2 divided by 6 into x plus 5 plus c1. So here 2 ones are 2 threes are. You can write this is in the form of what? Which will become 1 by 17 into log of x minus 2 divided by x plus 5 into 1 by 3, isn't it? Plus c1. Now this is according to 1 by 3 log m into n. Log m into n is nothing but log m plus log n. Now 1 by 3 plus c1 is nothing but c you are getting. So that is your answer. That is 1 by 17 into log of x minus 2 divided by x minus 5 into log of plus log of 1 by 3 plus c1, which will become 1 by 17 into log of x minus 2 divided by x minus 5 plus c. Log of 1 by 3 plus c1, and that is your final answer. I hope you understood this one. So dear students, these are all the problems you are going to study under those formulae. In the next session, we'll be studying some more problems on those formulae. So do remember this formulae. Keep watching. Have a nice day, dear students.